In this video we shall talk about triggers. In databases, a trigger is a special object describing an action to be performed automatically in specific situations. These specific situations depend on DBMS, and you may see then in different DBMSs you may cover with triggers a lot of different situations. But the approach is not compatible among DBMSs. So for instance, if you have to migrate your database from MySQL to Microsoft SQL Server, you have to not only change the syntax of your triggers, but to rewrite the trigger logic from the scratch. That is why obviously you have to refer to the documentation of your particular DBMS. Nevertheless, data modification logic of triggers has something in common in different DBMSs. As long as data modification operations are insert, delete and update, you may perform some actions before that operations, instead of those operations, or after those operations. And the next huge idea we have to review is how row-level triggers and statement-level triggers work in different DBMSs. Imagine we create a trigger on update for such a situation of data modification. This is the initial state of our table and this is the final state of our table. Row-level triggers, those are, for instance, in MySQL, are executed each time a record is modified. So we modify 1, 2, 3 records and there is 1, 2, 3 executions for our trigger. Inside our trigger we may use old and new keywords to access old and new values of data. But for instance, if we have not MySQL but Microsoft SQL Server, we have statement-level triggers there, and that statement-level triggers are executed once per the whole statement, the whole query. Inside the trigger we have such virtual tables as inserted with new values and deleted with old values. And there is a huge problem here. The order of these records in these tables is not the same. You may see it here. So you may not rely on records order, but you have to look at the values of some key field in your table. And if that value of the key field is also changed, that's an unresolvable problem for statement-level triggers. Because you may no longer know what is the equivalent of a record from here and a record from here. And in such situation, of course, row-level triggers have a huge advantage. But such situations, when you change the value of a key field, are extremely rare, so that's not really the problem. Now let's discuss typical operations to perform with triggers. The first is complex cascade operations. For some reasons, maybe in some situations, your DBMS is not capable to perform some complex algorithm for your cascade operation, and you may implement that yourself with trigger. Of course, you may use triggers to update caching tables or fields, because you may associate your trigger with some data modification operation, and once the data is modified in some table, you may update the data in some another table. With triggers, you may achieve data consistency implementation and control, because once some data is changing in your database, you may enforce some rules on how the data may be changed and how the situation may look like in the final state of that operation of data modification. Once you have that control and implementation on data consistency, you may implement and control some business logic. Imagine that in your system there has to be at least one administrator or something like that, so that's the business logic and that's the data consistency also, and you may implement and control it with triggers. Earlier in our course we've mentioned that with triggers we may achieve complex relationship cardinality control. For instance, imagine that you have system administrators and you have servers, and there is a rule that one system administrator may control no more than 3 servers. So that's 1 to 3 cardinality, and you may control it with triggers. In the previous video we were discussing such objects as checks. And with checks and with triggers we may control format and so on, but checks have limited capabilities and triggers have a lot of capabilities of that control. You may check any value, any condition, anything like that, and once that rule fails, you may fail the whole operation, abort the whole operation. But sometimes it's better not to abort the operation, but to correct something. Imagine that we have a table with first and last names of some users, and we know that the first and the last name must start with uppercase letter and all other letters must be in lowercase. So why not to correct this information with trigger? We may just convert the whole string to lowercase and then make first letters the uppercase letters. And yes, triggers give us a lot of capabilities, but they may significantly decrease database performance. So be attentive when creating a trigger, because you may significantly decrease your database performance. In order to avoid this situation, read documentation and perform experiments to analyze the performance with trigger and without trigger. Now let's review an example on how to create a trigger. In our file exchange service we have such a table with a lot of statistics and we have to update that table depending on some user actions. We may either recalculate all values every time a trigger was called, but it is slow, it's a bad situation. Or we may just update it as increase or decrease proper fields, and it's more complex of course, but it's significantly faster, so we shall go this way. As long as our statistics is mostly about files, their quantity, their volume and so on, we have to create triggers on file table. Please create triggers for user table yourself, and once something is updated here, we have to update something there. So we have to create 3 triggers: after insert, after update and after delete. But why after? Why not before? Because of course nothing prevents us from creating before triggers here for our files table. But we do not want those before triggers, we want after triggers. Why? Please pause the video and try to find the answer yourself. The reason is the next. Imagine the timeline. We have some operation, and if we have before trigger and that operation fails, DBMS has to abort not only the operation itself, but all trigger actions also. But if we have after trigger and the operation fails, this trigger is not executed at all. So we save the effort of our DBMS, we save performance. Let's go on with our triggers. First, we have to clear the today's statistics each new day. And it's convenient to use a stored procedure. We shall discuss those procedures in the next video. And of course, we may use this code directly in the trigger, but creating a stored procedure is more simple approach. This is the code of such a procedure. It checks if a new day has begun, and if it's so, it clears the statistics. And here are our triggers. This is after insert trigger. First, we have to clear the statistics for each new day, and then we have to update information to add something about new files arrived to our file exchange service. After update trigger is a little bit more complex. Here we have to check if this updated file was uploaded today, and if it was, we have to correct some today's statistics. Then we have to check for the new day and clear statistics and update our global overall statistics that is not dependent on the current date. After delete trigger is a little bit simpler than after update trigger. Here we also have to check if the deleted file was uploaded today and correct the today's statistics. Then we have to check for the new day and update the overall global statistics. The last example here is how to block an operation using a trigger. Imagine we have to prohibit deleting the last user from administrators group. Here we may use before trigger, not after. And then we check if there is no more administrators as user in this administrators group. We have to perform such a trick. We are creating an exception in database workflow and we put some meaningful message here. Unlike with checks, we may use meaningful messages in triggers. And that's all. The operation will be stop and that last user will remain in administrators group. Now we'll take a quick look at Sparx Enterprise Architect and MySQL Workbench and how to create triggers there. In Sparx Enterprise Architect we have to right-click on Table, select Features, Constraints, because triggers are constraints, and here we see our triggers. We of course may add some new triggers, but we may see our already existing triggers. We may edit them, save, and so on. In MySQL Workbench the logic is the same. Right-click, Edit Table, switch to Triggers tab, and we see our triggers here. We may edit them, update them, save them, or even add new triggers if we have to. That's all about triggers, and in the next video we shall discuss stored functions and stored procedures.